Here is a question asked for 6 marks in March 2018, where the question says, let A be the set which is defined in such a way that it has set of all x which belongs to integers and x lies between 0 and 12 inclusive on either side. Show that the relation which is defined as set of all ordered pairs A comma B such that A and B belongs to the given set A and difference of A and B is divisible by 4 is an equivalence relation. Further, find the set of all elements which is related to 1. Also write the equivalence class of 2. So first, to prove that it is equivalence relation, we need to prove that it is reflexive, right? So to prove that the given relation is reflexive, let us assume for all A belongs to the set A minus A modulus of that will be 0 is divisible by 4. Therefore, A comma A belongs to the relation which in turn says R is reflexive. Let this be statement 1. Now we need to show that the relation is symmetric. So let A comma B belongs to the relation for all A and B from set A. Then we know modulus of A and B is divisible by 4, which also indicates modulus of B and A difference is also divisible by 4, which means B comma A also belongs to the relation which says R is symmetric. Let this be statement 2. Now, to show that the given relation is transitive, let us consider 3 numbers from the set A such that A comma B belongs to the relation and B comma C also belongs to the relation. So let the difference of A and B be equal to plus or minus 4m and the difference of B and C be equal to plus or minus 4n as it's a multiple of 4. So by adding above equation, we get A minus C is equal to plus or minus 4 times M plus N, which indicates A comma C also belongs to the relation. Therefore, we can say R is transitive. Let us take this as the third statement. Now, from statement 1, 2 and statement 3, it is very clear that the relation R is equivalence relation. Now coming to the next point, set of all numbers which are related to 1, set of all elements related to 1 is 1, 5 and 9. And the next part is equivalence class of 2. The equivalence class of 2 will be given by equivalent class of 2 is given by 2, 6 and 10. So as the 6 mark question, how the marks are distributed is, when you prove this is reflexive, you get 1 mark. When you prove that it is symmetric, you get 1 mark. When you prove that it is transitive, you get 1.5 marks. And finally, using these statements, when you show its equivalence, you get 1.5 marks. And showing the set of all numbers which are related to 1, you get 1 mark. And equivalence class of 2, you'll get 1 mark. So totally you get 6 marks in this manner. Show that the function f, which is defined from real numbers to real numbers, and is defined by f of x equal to x divided by x square plus 1 for all x belonging to real numbers is neither 1 to 1 nor onto. Also, if another function g is defined from real number to real number such that g of x is equal to 2x minus 1, find f of g of x. So to show that it is not onto as well as not 1 to 1, we just need some example. So let us take this particular example. Here f of 2 is equal to f of 1 by 2. Both are equal to 2 by 5. But we know that 2 is not equal to 1 by 2. So which is evident, f of x is not 1 to 1. Okay. So now to show that it is not onto, let y be equal to 1 by root 2, which is a real number, which says f of x is equal to 1 by root 2. That means x divided by x square plus 1 is equal to 1 by root 2. After simplifying, we get x square minus root 2x plus 1 is equal to 0. And the discriminant of this relation, this quadratic equation, is nothing but minus root 2 whole square minus 4 into 1 into 1, which is less than 0. Therefore, the value of x is not real. Therefore, it says the function f of x is not onto either. So we have proved now it is not 1 to 1, not onto. Now coming to the second part of the question, g of x is given by 2x minus 1 and we need to find f of g of x, which is f of 2x minus 1, which can be further written as 2x minus 1 divided by 2x minus 1 whole square plus 1. If you further simplify, you get 2x minus 1 divided by 4x square minus 4x plus 1 will become 2. So this is our g of f of, that is f of g of a. So coming to the marking, so we have to prove that is 1 to 1, not 1 to 1. So we have taken a particular example and proving that it is not 1 to 1 with a right example will give you 2 marks. And it is not onto by taking a right example will give you another 2 marks. And finding f of g of x is also going to give you another 2 marks. So totally you get 6 marks in this way.